in this lesson, we are going to be talking about quadratic equations and specifically how to graph them. So one of our goals for talking about quadratics is to know where the vertex and the axis of symmetry are, and also to know that this shape is called a parabola. We are going to talk about standard form specifically and what that means. That's going to tell us how the parabola is opening. We're also going to be able to tell if it has a maximum or a minimum. And we're just going to be looking at the graphs and doing some information with that, okay? So to start out, a parabola is the shape that you get when you graph a quadratic function. A quadratic being the ones that you have factored before and solved. So there are a couple of different pieces that you need to know. First up is the axis of symmetry. The axis of symmetry is the line that cuts the parabola in half. So if you were to fold the parabola so that each side matched up, for example, so that this point, if you folded it on a piece of paper, matched up with this point, and this point touched this point, etc., the crease of the paper would be the axis of symmetry. The cool thing about parabolas is that they are symmetric on either side of that axis of symmetry. So again, if you were to fold it in half, all of those points would match up. The vertex is the lowest or the highest point on the parabola. So a lot of times you'll see at the bottom, sort of that bottommost point, if you're talking about the range, it's the lowest that it goes. That is the vertex. If we were to flip this parabola so that it was opening down and it looked like this, for example, the vertex would be up here, and that would be the highest point. The y-intercept is the point where the graph intersects the y-axis. There is only one of those. No matter what parabola we're talking about, there is only one y-intercept ever, okay? X-intercepts, there are the points where the graph crosses the x-axis, and there are generally two. Not always. There are exceptions to that rule, but for the most part, you'll see that there are two x-intercepts. We oftentimes also call these the roots, or you might see the word zeros. Either one of those is used interchangeably for the x-intercepts, okay? Standard form is what we're going to be talking about today, and that is the form of y equals ax squared plus bx plus c. That is standard form. A lot of times you'll see this also in an equation where you'll see ax squared plus bx plus c is equal to 0. That is standard form as well. When you're looking at standard form, the value of c is the point where the graph crosses the y-axis. So your y-intercept is always 0 and then whatever c is. And then we look at A to tell us which direction the parabola opens. If A is positive, the parabola opens up, and if it's negative, the parabola opens down. And we're going to look at a couple of examples of these so that you can see what that really means, okay? So here is a standard form equation. Notice it's y equals 5x squared plus 10x plus 3. Let's just talk about real quick what these are. 5 is the A. 10 is the B, and negative 3 is the C. Now, notice A is not 5x squared, A is 5. A, B, and C are always numbers, and they are the coefficients of the terms. We can find some different things. So the first thing we can find is our axis of symmetry and our vertex, okay? We do those by finding the x coordinate, and we use the formula negative b over 2a. So we're going to take our b value, which is 10. We're going to make it negative. And then we're going to multiply 2 times our a value, which in this case is 5. We're going to simplify that, and we get negative 10 over 10, which is negative 1. Now, this negative 1 tells us two different things. When we are looking at the vertex of the parabola, the vertex is going to be a point, and that point is going to be at negative 1 something. We don't know the y-coordinate yet, but we do know the x-coordinate. We also know that the axis of symmetry is going to be at x equals negative 1. The axis of symmetry is a line and therefore has to be a linear equation, and it will always be x equals that number, whatever the x-coordinate of the vertex is. If we go back, let me go back to that graph here, you can see that the axis of symmetry goes through the vertex, right? Because they share the same x value. So in this case, x was equal to 1 for the axis of symmetry, and the vertex was at 1, negative 4. those two values will always be the same. And that's what we're finding when we do this negative b over 2a. We're finding that x value that's the same, that is shared by the vertex and the axis of symmetry. Now, how do we find the y coordinate, this spot that I have open here? We're going to take our x value, -1, and we're going to plug it back into the equation for the x's, and we're going to solve to see what y is. So we know that y is equal to 5 times -1 squared plus 10 times -1 minus 3. Pretty straightforward to just evaluate that, and we get 5 minus 10 minus 3, which is -8. So the vertex is at -1, -8. We have now found the vertex of our parabola. Then the question becomes, does it open up or down? Well, we look at A for that, and A is positive, which means that the graph opens up. So this vertex would be located at a minimum. It's going to be the bottommost point. Therefore, it's going to be a minimum on the graph. Let me show you what that looks like. So here's the graph. You can see that our vertex is at -1, -8, and it's also a minimum because it's the bottom point, right? Whoops. And so the graph is opening up because of that +5 being our A. Notice also I didn't find this, but you can very easily see that -3 is the C. The y-intercept is at 0, -3. Now we have a couple roots here. We didn't take the time to find those. That's a little bit of a different form when we talk about that. But eventually we'll also be talking about how to find the roots or the x-intercepts of the function as well. Let's look at another one. So here is our standard form equation. We want to find a couple things. We want to find the vertex. We want to find the axis of symmetry. We want to know if it opens up or down. And that will then tell us if it has a max. You know what? Let me rewrite this so that they're the same. If it opens up, it has a minimum. And if it opens down, it has a maximum. I'll write those in the same order so that you know that they correlate, okay? So here might be a good time to pause the video, work through the process, do your -b over 2a, plug it in, see what you get, or pause it at each step, however you want to do it, okay? So to walk this through, the first thing we're going to do is we're going to take our -b, and let me label these real quick for you. A is -7, whoops, B is 21, and C is 38. So we're going to take -b, so -21 over 2 times -7, which gives me 3 over 2. That is the x coordinate of my vertex at 3/2, or 1.5. It's kind of nice to keep it as this improper fraction because we're going to be plugging in. And then my axis of symmetry is also at x equals 3/2. From here, I'm going to plug in 3/2 for x, and I'm going to solve to get y. I would strongly urge you to try to do this without a calculator as much as you can, just because it will help you get more comfortable with fractions, with your order of operations, with a lot of the math that you really kind of need to know how to do mentally. So 3/2 when we square it is 9 over 4, and 9 over 4 times -7 is -63 over 4. 21 times 3/2 is 63 over 2. And then 38. And then here's where, if you want to grab your calculator, go ahead and plug those in. This is just a side note, and we'll go over this more, but if you're using a graphing calculator, to enter a fraction, if you push that green alpha button and then the y equals, you get a little menu that pops up, and you want to hit enter to choose number 1, which is n over d. So you should see this. And then that will give you 2 boxes where you can actually enter the fractions. So let's take -63 over 4 plus 63 over 2 plus 38, and we get 215 over 4. And it's totally fine to leave that as a fraction. We're not graphing this, so we don't really care about what the decimal approximation is at. We want to be as exact as we possibly can. So we found our vertex, we found our axis of symmetry. The question is, does this open up or down? Well, we look at our -7, and that tells us that it opens down. Whoops. As you can see on this graph that has appeared here, the graph will open down because that -7 is our A. So we're going to say that it opens down. Oh my goodness, I was going to try to box this. Anyways, which means that we have a maximum at the vertex, okay? So it opens down, which means that we have a maximum. Our maximum does not match. So anyways, ignore the points. Sorry. Ignore the points because that's not correct. But this is what the graph would look like. It opens down, and we would have our axis of symmetry at 1.5. And then our vertex would be all the way up at 215/4. And then it's opening down, and we have a maximum. So hopefully you kind of get the algebra of this. I'm not too concerned about the graphing because we can use Desmos to graph that. And if you want to use Desmos to graph your function to check your work, feel free to do that. That's a great tool to use. But I'm hoping that you can figure out or understand how to use the -b/2a to find the vertex as well as the axis of symmetry, and then how you're plugging in and the math that you're doing. As always, if you have any questions, let me know. But hopefully you feel like you're understanding pretty well how to work with parabolas.